We are multiplying radicals. This will be nice and fast because you know what you're doing. So, basically, the rule is that anything that's underneath a radical gets multiplied together, and anything that's not gets multiplied together. So, for example, you don't have to worry about like radicals or anything like that. If I had something like 2 root 5 and I wanted to multiply it by, I don't know, 3 root 6. First of all, this is all multiplication, however it's written. Don't think that you're foiling here because these are not binomials. So it's the same thing as 2 times square root of 5 times 3 times square root of 6. That's all it is. It's just all multiplication. Unless I had a plus or a minus in there, then I'd have to FOIL. But anyway, we've kind of already been doing this, right? When you get all your answers and you simplify them down, don't you have a line like this where you just multiply everything that's not in a root and put it out in front? Then everything that is in a root, you just put at the end? That's basically where we're at. So 2 times 3 gets me 6, and then I have 5 times 6. So I multiply them together and leave them under the square root. The only thing you have to check for is that your new answer can't be simplified any further. So I just have to look at the square root of 30 and see, are there any perfect squares that divide into 30? Perfect squares? No. So I'm done in this case. But if it had been like square root of 32, for example, well, that does have a perfect square, and then I just have to simplify it. So that's literally all there is to multiplication. It's just how tricky can the questions get. So, I don't know. Let's just do, I like number 1. So on that sheet you're looking at, you have 3 root 12 times the square root of 6. Okay? Now, yes, you could simplify the square root of 12, but I wouldn't even bother. With multiplication, don't bother. Multiply it all together first, and then if your answer needs to be simplified, you can. So if I multiply all the numbers that are not under the root, it's just 3. Then if I multiply 12 and 6 together, what's that get me? 72. And now I just simplify that one answer instead of simplifying multiple times. You get what I'm saying? I would just simplify one time at the end. So, are there any perfect squares that go into 36? Yeah. Well, I mean, into 72, and 36 is one that goes in. So split that up into square root of 36, square root of 2. Just bring down that 3. So now I just have 3 times 6 times square root of 2, or 18 root 2. That's basically it. So let's look on this sheet. Is there one that's maybe super... Oh, variables. Yeah, let's do ones with variables in them. Let's jump down to number 9. Looks good. So number 9 looks like this. Negative 3 square root of 7r cubed times 6 square root of 7r squared. Okay, well, I'm still doing the same thing. Multiply everything not in the house, put it together. So that would be a negative 18 out in front, and then a big old square root. Everything that's in the square root just gets multiplied together. So 7 times 7 gets me 49, and that would get me r to the what? Fifth. R to the third times r squared would be r to the fifth. Excuse me. And now I just have to simplify this answer. So go ahead and try it. See if you remember how to fix this answer so it's fully simplified. Because you're going to have to deal with the square root of r to the fifth. Yeah. Oh, you have it? Let me break it up first. So I'd split it up, give everybody their own. What is the square root of 49? 7. And now, how do I handle this? Just, what do you do with this? Yes, I'm always trying to do my exponent divided by my index. Remember, there's a teeny tiny 2 there that we don't write. I can't do 5 divided by 2. So then I go down and I say, can I do 4 divided by 2? Yes. So I have r to the 4th, and that would be r to the 1st. What is the square root of r to the 4th? Yes, and then that just stays. So then all I have to do is the 18 times 7, which is 70. Is it? I believe you if you say it. Does that make sense? So, I mean, that's why I'm saying multiplication is not that bad, because you kind of already know what you're doing. So try 8 real quick. And then we'll try a different style of multiplication ones. There are different ways to do a problem like this. So you might have simplified this first one by itself and simplified this one by itself and then kind of multiply their answers together. You can do that. I personally don't like to do that because I like to just simplify it one time. So I do all the multiplication first and then simplify my answer. Because sometimes you could simplify it, but then when you multiply it together, you might have to do it again. Ugh. So it's not wrong, but I wouldn't do it that way. So if I multiply all this together, there's only a 4 out in front, and then everything in the root gets multiplied together. So 18 times 3 is 54. And that would get me a to the 4th. And now I just simplify this. 4 square root of 54 does split into 9 times 6, and then I have the square root of a to the 4th. So that's just a 4 times 3 times square root of 6, and what's the square root of a to the 4th? Yep, so my final answer is just 12, a squared, square root of 6. Did you get it? So even if you did it differently than I did, as long as you end up here, it's fine. Okay, if you start looking at ones like 11 and on from there, you'll notice that now I do have binomials. So, I don't know, let's just do one like, let's do 12. So, 12 has us distributing a 2 root 5. Root 6 plus 2. So I have to distribute just like I normally do, right? I'm just going to take this thing out in front, and I'm going to multiply it by this, and I'm going to multiply it by this. You just have to be careful when you do it. So when I'm multiplying these, 2 root 5 times root 6, what do you think that gets me when I multiply this by this? 2 root 30, absolutely, because you're only going to multiply whatever's in the roots with each other. So that's 2 root 30. And then when I multiply 2 root 5 times 2, what does that get me? What'd you say?
I'm guessing 4 something. Either 4 or 4 root 5.
2 root 5 times 2. 4 root 5, exactly. Because the 2's are not in the house, so they get multiplied together. And then there's nothing else for me to multiply the root 5 with, so it just stays like that. Oops. The ink wasn't quite dry and I touched it. And then I just asked myself, now it's a problem like you had on last night's homework. You're trying to add these radicals together. They're not like radicals. I just got to see if I can make them be. So, does the square root of 30 simplify? Are there any perfect squares that divide into 30? No, right? So I actually am done in this case. But I always have to check because I might be able to fix this and then have, but in this case I don't, so I'm done right there. Let's try 14. So that's square root of 3 times negative 5 root 10 plus root 6. So go ahead and multiply the root 3 in, but don't go any further than that. So just multiply those two things by the square root of 3. See what you get. Ashlyn, what do I get?
Negative 5 square root 30 plus square root of 18.
Perfect. I'm just multiplying what's in the roots together and what's not in the roots together. So this times this, there's nothing to multiply the negative 5 with, so it just stays. And then 3 times 10 gets me 30 in the root. And then root 3 times root 6, root 18. All right, so now I'm here. Maybe I'm done, maybe I'm not. We've already talked about how 30 doesn't have any perfect square factors in the last problem, but this guy does. So even though I'm probably not going to be able to combine them, you do need to simplify this one. So that splits into what, 9 and 2? So I get negative 5 root 30 plus 3 root 2. And that's as far as I can go. I'm done. How do we feel about distributing? Yeah, it's hopefully not too bad. So the only other thing that we have to worry about is foiling. So if we look at something like, oh, what'll we pick? What'll we pick? How about just 21's fine. So 21 has negative 2 root 3 plus 2, and I'm going to multiply that by square root of 3 minus 5. All right, so this is a binomial times a binomial. This is where we FOIL, right? So go ahead and try it. Just do the FOIL part. First outers, inners, last. So you'll have 4 terms there when you're done.
Is this on the paper?
Yeah, 21 on the back. Okay, let's see what we get. I hope you remember how to FOIL. So, F stands for first. So I'm going to multiply negative 2 root 3 times root 3. So what's that going to get me? Negative 2 root 3 times root 3 would get me,
-2 9.
yes, negative 2 root 9. Is everybody okay with that?
How'd you get that?
Because you're going to, there's nothing to multiply the negative 2 with, so it just stays. And then root 3 times root 3 would be root 9. Right? Because if they're both in the house, you multiply them together. So there's my
Root,
first.
So wouldn't it go back down to 3?
It will, but I'm not there yet.
Oh.
So there's first. Then outers, so that would be negative 2 root 3 times negative 5. So now that should be positive 10 root 3. Do you agree? Inners, 2 times root 3 is just a positive 2 root 3. And then the last 2 times negative 5 should be a negative 10. So double check that you have those 4 at some point. Now, I can simplify this further, so I need to. Ryan's right, the square root of 9 is just 3, so negative 2 times 3 just gets me a negative 6 right there. And then, check this out, I have like radicals right here. 10 root 3 plus 2 root 3 would get me 12 root 3, and then I just have this minus 10. So now I can put the negative 6 and the negative 10 together. So, final answer, negative 16 plus 12 root 3. How'd you do? We're okay? So, why don't we stop this here?